Hi guys, making another video. And I do hope that these sort of do the job from what you guys will need. I'll never know unless you tell me. So if you feel, some of you I do talk to, so I know where you're at, but some of you I don't. So for those of you that haven't really reached out, please just, take some time and just say, I watched the video and then help me with this, and that way I know to keep making them. So anyways. We're into 8.2. You don't have to pound through these. Uh, I'm making sort of back-to-back videos. I'll probably make 4 videos today and then a few more on Sunday or the week. Um, I will also be extending the chapter 8 homework at some point, but I want you guys to sort of stay on pace. So, um, but yeah, don't just like go, okay, I gotta do 8.1. Now I gotta do 8.2. Take some time and really try to learn. I think you'll get something out of this chapter. Um, Now, notice too that a lot of these problems, oops, sorry, my laptop just closed on me. So, but I was saying, notice that a lot of these problems have help. So you might not need to watch the videos, but I'll always look out for ones that don't have that. And you might like their help more. You might, I don't know. But we're still in U subs, so I could have probably attached 8.2 into the 8.1 video, whatever. So just remember, these are probably going to feel more complicated when you do them on your own, but just do your best. So it tells us to do substitution. Now, remember that really means U sub. We are going to learn something later called trig sub. Um, trig sub's kind of annoying, but whatever. My point in the last video with U sub is that you're going to see a lot of options, right? If you guys have seen the Hangover meme where he's like looking at numbers, I'll try to pull up the next video. You're gonna see these just like that, right? Like Zach Galifianakis, like seeing numbers in front of his face. Um, that's problematic because that means we have too many things running through our head. There's multiple options here. You might say this is you. You might say this is you. You might say this whole thing is you. Okay, so you have to look out for some kind of connection. So what do we notice is going on? We have two trig things. So that's probably one of them's probably U, one of them's probably DU. This ln is just sort of a dummy thing thrown in there. So if I let U be cos, then DU, right, and you have to try these and learn the hard way, DU would be negative sine X. I don't have that. Plus there's an 8. I can't just make up an 8 here, right? That doesn't work. Whatever I take for my DU, it has to almost perfectly be there other than division or multiplication. So then, since that didn't work, I probably want this to be U. And if that's U, what's du? It's cosine of x, okay? Which I have right here. That's perfect. So that part and that part are going to be du. Should write a dx here. So what we really have is ln instead of sine of x plus 8. I called that u. I have ln of u. And then the cosine x dx, that just becomes du, right? Magically. And then we have to know how to take the antiderivative of ln u. That's just a formula in the book. So make sure you check the table of integrals for that. I believe it's u ln u plus u. Don't quote me on that. Um, so again, you guys want to know these, but yeah, sorry, it's minus. I was close. U ln u minus u. Okay. The reason I'm not going into why that is what it is, we'll learn later how to find that ourselves. Um, but for now, that's just straight out of the table. Okay, so make sure, you would look in the back, you say, hey, what's the formula for antiderivative or integral of natural log of u? It's going to tell you this. Okay. and then just substitute back u as sine of x plus 8, and you get your answer, okay? I don't know if I want to go through every single problem, so if there's repeats, I'm going to skip them because I don't lose my voice. I have to make a lot of videos. Um, All right, what do we have here? We have x sine 8x. So let me see, make sure. Yeah, okay. So we have a formula. I do want to show you guys this from the book so that you're clear on what it is. I could just write it out, and honestly, that doesn't hurt, but I want to give you sort of a solid foundation reference point so that you see that these are not just random formulas I'm making up. I wish I was that good where I could just say, here's a formula that always works. So this is not a substitution section as I thought the first one was. This is called integration by parts. And it's probably for now going to be the hardest thing you've ever done in math. So it's on page 525 in the book. This is the formula right here. Okay. You're probably like, what does that mean? So we have u dv antiderivative is equal to u times v. I'm going to try to give you the basics of this. So it's saying when we have something like this, and there's tricks too. There's a lot of good videos on this for sure out there. There's shortcuts on what to pick for u, what to pick for dv, go into what that means. So we have something with a u, something with a v. That's the first observation. We also have a dv instead of a v, right? It doesn't say antiderivative u times v, two functions, one's u, one's v. It says we have antiderivative u and times dv. So this dv means whatever v is, we have the derivative of that thing. So that's a huge part of this. And then what we'll get, and it's not easy, guys. This can be multiple steps. What we will get is whatever u is times v, so uv, minus, okay, this formula has another integral. So it's minus antiderivative of v times du. So long story short, let me go back to this here. So make sure you guys write this formula down and make sure you look in the book for this. But for the problem we have, I can even leave this up. What this is saying, let's just directly apply this formula, is we have two things, right? So we have, so integration, this is called integration by parts, IBP, integration by parts. We have two things, right? This is not a U-sub. We have this is one thing and this is another. We don't know which one's U, which one's V or dV, okay? But I will tell you right now, when you have a term like x or x squared, or x cubed, or even if we had stuff added to these, and our other term is like e to the x or sine or cos, and maybe ln, maybe we'll put a star there. These are better candidates for dv, and these are better candidates for u. Okay, because sometimes we'll have to apply multiple iterations of this formula, and you're going to hate doing it. Trust me, or mark my words, you will hate doing integration by parts when there's more than one iteration of it. Eventually, when we have these as u, when we keep taking du of those, the derivative of them, it's going to get broken down to a constant, right? So if I took derivative of x cubed, I get 3x squared. If I took the derivative of that, I would get 6x. Took the derivative of that, I finally get 6. We always want to end up down here. That means we're going to be on our last step of doing integration of parts. So the formula, let me write it here, is antiderivative u dv, uv minus antiderivative of v du. How you want to do these, and this is more from my tutoring side. How you want to think about this is you want to make a box, okay, like this. And we're going to split the box in 4 equal parts. Okay, one of them is going to be u, one of them's du, one of them's dv, and v. So if my u is x, then what's the derivative of that? It's 1. And if this is u, then my dv is sine of 8x. Now this is not easy. So my dv is this. Now I have to figure out what v is. But look how they're related. dv, if I integrate that, I would get v. So to figure out what v, and we have to do this because it says right here we need to know what v is, we take the antiderivative of sine of 8x. And this is straight out of Calc 1. Okay, it's a u sub, so it's going to be, I'm not going to show you all the steps, but it's -1/8 cos of 8x. So you might need to practice just this part, and you're going to get that from doing integration by parts. So anyways, we need that. Okay, that's v. And then we plug, so we have 4 things here, and this formula requires 4 things. We need a u, we need a v, we need a v, and a du. So the answer is going to be x times this, because it's u times v. So this is u, this is v. So the antiderivative is x times -1/8 cos 8x. Okay, that's right, guys. It looks bad, but that's it. Minus antiderivative of v, again, this nasty things, we have minus, so should put plus 1/8, right? Minus cos of 8x times du, but du is just 1, so that's it. And then you just have to, this part's done. This part's done. And then we have to integrate that, and we would get, so let's write this, -x/8 cos 8x as this part. And you could try this antiderivative, but you will get -1/64 sine 8x plus a constant. Okay. Now, you might say that's too fast. I have no idea what you just did, but that's what this whole section's on. So you're going to get practice with this. But mark my words, when you see an x squared here or an x cubed or anything like that, that's going to be multiple steps and it gets messy. Okay. Way harder than Calc 1. And Calc 1 was just sort of like a brief intro to, really intense algebra. Question 3. So this, this is a great problem. This is why I love Pearson, because it's not just making you write and write and write. Typically a Calc 2 class is just tons and tons of steps, and you're gonna get sick of them. Okay. So I'll let you guys work on this, but let's just say, since this is x, since this is sine, this is the better candidate for u, this is the better candidate for dv. Okay. So so there we go. Okay. Next question. Question 4. Ooh, well, I did say we may have E. Okay, so um, these problems have multiple steps. First part is to set it up. Second part is to solve, and solving means you're gonna have to do this part too. Okay, so we have what 2 things here? We have 5t, we have e to the t dt. Now you have to see and look for 2 things because we know we have to treat it as if we're looking at this. One thing's u, one's dv. Okay. And dv is a function, right? So, okay. We said, well, we have things like x, or in this case, t. That's the better candidate for which one, u or dv? Well, we said u. So we could pull that 5 out and might as well. So we'll say that this is u, and then by default, this is dv. Okay. So we'd make a box. We have u, which is t. du is 1. Actually, this is u, du. This is dv, e to the t. And then to find v, we have to take the antiderivative of dv. What's the antiderivative of e to the t? It's just t. And then we plug into our formula. So we get t e to the t, uv, these two, minus the antiderivative of this times this, which is this. We have a 5 out here. Remember, I pulled a 5 out, so it's really 5, 5. And you can see that that's which one? This one. Okay. Anyways, so practice these guys. I'm not doing like, I wish we were in person for this stuff because this is hard. This is a really hard section, but you guys do have help, there's videos here too, and help me solve this. So, but I do want to just make sure you guys see that what we're doing is we're like, okay, same problem, different problem. It's all this formula. And when I pick my u, that's going to go in this box. My du is here. Whatever's left is dv, that's v. So my u here is 4x. Okay, so 4x. Then du is 4. My dv is whatever I didn't pick for u, and that's e to the 3x. So this is, and then if I integrate that, right, it's 1/3. You can check this, e to the 3x. So practice that. Okay, what's this? Well, it's a u sub, right? U is 3x and du is 3 dx, and I move 3 over. So I have e to the u 1/3. Integral 1/3 e to the 3x. Okay. You got to practice that. Okay. They may or may not go through that step in the help. Okay, but anyways, once I do that, I plug that into this formula, which was uv minus antiderivative v du. So I say u is this, v is this, v is this, du is that. Okay, and you get your answer. Okay, so what have we learned? Well, we've learned that when we have something with x or t, like this guy, that's going to be u. So we let that be u, and that means this is dv. Okay. Now in this case, though, we're going to have to integrate that. So that may or may not be a problem, right? So for this one, since I can see the answer choices here, I can see that they didn't pick that for you. And if you look back, I put a star around when ln is a choice. So when you have an ln and an x, you want u to be the ln term. And now we're going to let dv be the 14x term. Okay. You'll see why. What's du? If this is u, it's 1 over x, right? So that's our du. And to get b, I would integrate that and I get 7x squared. And then if you look at the formula, this is the answer. Okay. So plug this into the integration by parts formula. Okay. So again, I'm just setting these up for you. There is work left to do on these, but I want to kind of go through each homework question so you can see. Now we don't have an ln here, so we're back to using this is dv and this is u. Okay, so u would be 4x, dv is e to the 3x, then you make the box, and that's all they're asking here is to fill in that part. Okay. Okay. Now, even though this isn't cos or sine, it's still a trig. So you can think of this theta as x, but we're going to let u be 21 theta. dv is secant squared. Now you have to remember this. What's the antiderivative of secant squared? If this is dv, then it would be tan theta. Okay, so that's just a formula. You can check the table of integrals. And if this is u, then du is 21. Okay. And you can see that u, 21 theta times v, would be this one. So you know the answer is C. And then after that, after you get part one right, you're going to have to integrate that. And so that means we need to know from the table of integrals, what's the antiderivative of tan theta. And it's funky, so you have to look these up. I don't expect anyone to do them by hand. You can, but I don't expect anyone to. Okay. What we learned in the last one is when we have x with ln, that's when we want to flip the idea and say, this is now going to be my dv. This is my u. So dv squared, to get v, I have to integrate that. My u is ln x and du is 1 over x. So if I plug that into the formula, I would get minus, now dv times u, sorry, b times du is this. And we can easily simplify that and integrate it. And that will be the answer. So it's a good problem. But what we're on the hunt for, what we're looking for here is a problem. Let's say they gave us this. Sorry. Say they gave us this, where we want this to be dv and this to be u again, like normal. This is going to be multiple iterations. So we can expect to see that in the next one or two problems. And that's where you're going to hate the. We don't see it yet, okay? But I'll give you guys a hint on this one. You're gonna want to rewrite this problem. That's that. Okay. All right. So how do we do this one? Let's see. We have arc sine of 5x. It says to evaluate it using integration by parts. Any ideas on this? Okay. So this is tricky. I'm not exactly sure why they're saying integration by parts because it's a little more technical than that. You may or may not recall doing problems like this in pre-calc. So the way you think about this problem is you say, let's say sine inverse of 5x, and we're going to call this thing theta. Now this is funky, so just try to follow this. And then if we take sine of both sides, we'd get that, right? We know from trigonometry that when we have right triangles, that the sine of an angle is the opposite over hypotenuse. So you literally have to draw a right triangle for this and put this over 1, because when I put that over 1, I now have an opposite and I now have a hypotenuse. So let's call this theta. So make sure you label the angle in there. And opposite of this angle theta is this side, and the hypotenuse is 1. And so I can solve for this. Okay. I can solve for this. And if you do the Pythagorean theorem, this squared plus this squared is that. So it's 1 minus this squared rooted. So it's 1 minus 25x squared is this side. And then what? Well, what can we do? If we integrate theta, that's the same as integrating this, right? So let me write this. Integrate theta is the same, and this is the one we're trying to integrate. And according to Calc 1, right? What's the antiroot of theta? It's theta squared over 2. Okay, so what does that tell us? Well, if we took the sine of that, will that work? Let's see. Sine theta squared over 2. Give me 1 sec. don't want to do this one wrong. Um, want to use the triangle to do it. Okay, so this is on the right track, but I'm gonna say for this one, just to use the formula, and I'll give you the formula. Um, use hmm, hold on. Why am I not seeing it? Okay, use the formula. Here it is. So the formula is going to be given by 1 x sine inverse x plus this. Now, the way I'm doing it here should work, but I'm not seeing how to apply it to the triangle at the moment. So I may make a separate video on this on question 11, but I'll come back to that. But for that one, just refer to the formula for sine. Um, okay, now we have integration by parts. This one does look tricky, okay? But since so far we've used x as 1 every time, that's probably the best choice for you. And if we let that be u, then dv has to be that, okay? And then go through it. It might take a little bit of work. Um, okay, let's see. So, I think that should work, unless they do it opposite, unless they say that's b. But sometimes you have to try. If this doesn't work and you feel like it goes in circles, then try the other one. Say like let oh geez, what's that? Let dv be x, and then let u be this. You just have to kind of figure out uh, which one works. Okay, so it's trial and error. But again, this is a section where you really want to not skip over how we're solving it. So you don't want to just be like, okay, I get it. Okay. Finally, we arrive, right? This is what I've been sort of building for. Question 11 was a doozy, but don't worry about that question. This one you have to be able to do. This is expected that you're able to do this proficiently as a Calc 1 student. So um, in this case, because we have this as our alternate to an x, we do want to be consistent and say u is x squared. And so dv is that, right? And so the setup looks like this is du. I'm not going to make the square, but imagine I did. V would be uh, this. Okay. After one iteration, what happens is we have u times v. So we have x squared over 12 e to the 12x minus the anti-root of v du, which is 2x. So look what happens over 12 e to the 2x. Now, this is not going to be solved in one integral. we did get something here. So you kind of, if you're doing this problem, I would definitely write that part, right? I'd be like, okay, I got this. Okay. For the next part though, I'm gonna have to do another integration by parts. In other words, and because this minus looks harmless, but it's a pain. So I have to do a new one, right? I did that. I'm gonna make a new box. Here's my u, which is 2x root is 6. So let u be 1/6x. du is 1/6. And then this is dv. So my dv is 2x, and my v would be this. And so what we have is this. This gets messy, guys. So welcome to math, right here, right now. We have this. I'm going to put brackets. And then this is another iteration or application of integration by parts. And so it's u times v, 1/6, 1, 2. So we have 112 x e to the 2x minus, right? What I'm doing now is I'm reapplying integration by parts formula minus antiderivative of v du, right? So v 1/2 e to 2x du is just 6. So this, even though I have another integral, remember we're gonna have a minus applied into the what's inside the brackets. This is just something that's integrable, right? 1/12 e to the 2x. I can do that in one integral. I don't need integration in parts. But when I had this, because there's an x and e to the 2x, I have to do integration in parts for that. Okay, so how this answer will look is minus 1/12x e to 2x. And then what's the antiderivative of this? Well, it's minus minus, so it's positive 1/12. But then because I'm integrating e to the 2x, I'm dividing by that 2. So it would be 1/24 e to 2x plus a constant. So the final answer is that. So that's luckily it's like the second to last problem, but in this course, you have to be able to do multiple iterations to my parts. So before we move on, how did we know we'd have to do it more than once? Because we have squared. So imagine if you had a cube, that would be 3 iterations. That's crazy. 4 and so on. Okay. So you guys, I do expect you to be able to do that. Okay. Same thing, right? You look at it, we're like, oh no, oh no. That x squared tells me it's going to be 2 applications. So still want x squared to be u, cosine 5x to be. So that one's going to be a pain, guys, but just practice these, okay? You can see that this is a little different than the first unit we did. I'm definitely going to focus on making you guys master each technique, okay? So 8.1 was going sort of back to Calc 1. How do we do u substitution? 8.2 is how do we do integration by parts? Brand new, but I promise you of all, there's 4 integration techniques. We're gonna learn 2 more, but integration by parts is by far and away the most difficult, and questions 13 and 14 are the hardest versions of it, okay? So let me know if you need help on this, and good luck.